Your calculator just gave you the wrong answer. Not because it's broken. Not because you pressed the wrong button. But because you didn't know how to check it. In this lesson, you will learn how to round decimals correctly, how to estimate answers before solving, and how to use that skill to catch mistakes that most students never even notice. By the end of this video, you'll be smarter than your calculator. Welcome to the decimal series. Today, we will be talking about rounding decimals and estimation. Let's start with the foundation. Rounding means replacing a number with a simpler number that is close to the original value. We round when we don't need an exact answer, or when we want to quickly check if our answer makes sense. For example, the price of a jacket is $47.86. You don't say, I spent $47.86. You say, about $48. That's rounding. You already do it in real life without thinking about it. Here is the rule that never changes. Look at the digit immediately to the right of the place you are rounding to. If that digit is 5 or more, round up. If that digit is 4 or less, round down. Keep the target digit the same. This is called the 5 and above rule. Memorize it. Let's round 3.746 to the nearest tenth. Step 1. Find the tenths place. That is the first digit after the decimal point. Here it is 7. Step 2. Look at the digit to the right of 7. That is 4. Step 3. Since 4 is less than 5, we round down. The 7 stays as 7. So, the answer will be 3.7. Now round 5.682 to the nearest hundredth. Step 1. Find the hundredths place. That is the second digit after the decimal point. Here it is 8. Step 2. Look at the digit to the right of 8. That is 2. Step 3. Since 2 is less than 5, we round down. The 8 stays as 8. An answer will be 5.68. Now round 12.957 to the nearest tenth. Step 1. Find the tenths place. That is 9. Step 2. Look at the digit to the right. That is 5. Step 3. Since 5 is equal to 5, we round up. The 9 becomes 10. But wait, 10 in the tenths place means we carry over. That means 12.9 becomes 13.0. And that will be our answer. This is the example most students get wrong. When rounding up causes a carry, the whole number changes. Always watch for this. Here is the most common mistake in rounding. A student needs to round 4.348 to the nearest tenth. They look at all the digits after the decimal, 3, 4, and 8, and think the 8 means they should round up the value to 4.4. That is wrong. You only look at one digit, the digit immediately to the right of your target place. The target is tenths, and that is 3. The digit to its right is 4. Since 4 is less than 5, the answer is 4.3. Never look further than one place to the right. One digit. That's the rule. Now let's talk about estimation, and why it makes you more powerful than a calculator. Estimation means finding an approximate answer quickly, before you solve the actual problem. Here's why it matters. Imagine you're solving 3.7 multiplied by 4.2 on your calculator. You accidentally press 42 instead of 4.2. Your calculator shows 155.4. If you had estimated first that 4 times 4 is 16, you would instantly know something is wrong. 155 is nowhere near 16. Remember, estimation is your error detection system. Let's estimate 6.83 plus 4.17. Round each number to the nearest whole number first. 6.83 rounds to 7. 4.17 rounds to 4. Estimated answer will be 7 plus 4 equals 11. Actual answer is 11.00. That means the estimate was perfect. Now let's estimate 8.76 minus 3.24. 8.76 rounds to 9. 3.24 rounds to 3. Estimated answer is 9 minus 3 equals 6. Actual answer is 5.52. Close enough to confirm we're on the right track. Let's bring this into real life. Situation 1, shopping. Let's suppose you have $14 and you need to buy 3 items, which cost $4.75, $2.89, and $6.12. Now, the question is, do you have enough money to buy all 3 items? Let's round the price of each item first to $5, $3, and $6. Total estimate is $14. Actual total is $13.76. You have enough, but only just. Estimation told you in 5 seconds. Situation 2, science class. You need to find the area of a tabletop. You measure it as 1.47 meters long and 0.83 meters wide. Area will be equal to 1.47 multiplied by 0.83. Estimate value is 1.5 multiplied by 0.8, which is equal to 1.2 square meters. Actual value is 1.22 square meters. If your calculator had shown 12.2, you'd catch the error instantly. Now it's your turn. Pause the video and solve these 3 questions. Question 1. Round 9.253 to the nearest hundredth. Question 2. Round 7.965 to the nearest tenth. Question 3. Estimate 5.82 plus 3.47. Then find the actual answer and compare. Go ahead. Pause now. Here are your answers. Answer 1 is 9.25. The digit to the right of the hundredths place is 3. Round down. Answer 2 is 8.0. The digit to the right of 9 is 6. Round up. 9 becomes 10, so we carry over. 7.9 becomes 8.0. Estimate answer of question 3 is 6 plus 3 equals 9. Actual answer is 9.29. Very close, right? Your estimation was reliable. Here is your final challenge. A student calculates 12.36 divided by 3.09 on a calculator and gets 0.4. Without solving it yourself, use estimation only. Is that answer correct or wrong? Pause the video and decide. Let's check with estimation. 12.36 rounds to 12. 3.09 rounds to 3. 12 divided by 3 equals 4. The estimated answer is 4. The calculator showed 0.4, that is completely wrong. The student made a decimal point error. This is exactly why estimation exists. It caught an error in 5 seconds that most students would have submitted as their final answer. So, today you learned 3 things. How to round decimals to any place value using the 1-digit rule. How to handle carryovers when rounding up causes a 9 to become 10. And how estimation works as your personal error detection system in class, in science, and in real life. In the next lesson, we close out the decimal series with decimal word problems, the type of question that appears most on exams and homework. Make sure you're subscribed so you don't miss it. And if this video helped you, the next lesson is already waiting in the playlist. See you there.